This here is whey protein. With all the fitness hype on the internet, you've probably already heard of it, or maybe you've even taken it yourself. Many people know it's a protein concentrate. What a lot of folks don't know is where it comes from and how it's made. That's why I came here to the Mawa Institute of Technology, Whey Factory at Mawa. Yes, it's possible to make whey here. A few years ago, we came here to show how powdered milk is made. So today, you'll find out how whey protein is produced. Let's check it out. You know, we love coming here to Mawa to shoot cool videos. Look at this line-following robot, remote-controlled airplane, perfectly round concrete ball, biodiesel from cooking oil, wind turbine, electricity meter, bicycle with a display on the wheel. We've tested shark skin-inspired clothing, played with microgravity and free fall, and learned how to operate industrial robots. So maybe a lot of people weren't even surprised to hear they can make whey here. That's because Mawa offers various engineering and technology programs. The campus I'm at is the main one, located in São Caetano do Sul, less than half an hour from downtown Sao Paulo. Among their more than 100 labs, where students learn hands-on, there's an industrial pilot plant, like a mini factory, for food engineering students. Alright, whey is a protein concentrate, but few people know it actually comes from milk. More precisely, from milk whey, a byproduct of cheese production. So this is where our let's check it out begins. The first step is to take milk that's already pasteurized. That is, it's already gone through a process that eliminates disease-causing microorganisms. This one is semi-skimmed, because we don't want to deal with fat. The milk is placed in this tank, which has steam circulating through its walls, and it's heated to 34 degrees Celsius. It's nice and warm.
The next step is milk coagulation. For this to happen, I use an enzyme called chymosin, found in a commercial product called rennet. For this enzyme to work, I need to create the right conditions, maintain an appropriate temperature and pH. We achieve that pH by adding lactic acid. I'll also add calcium chloride to replace the ionic calcium lost during pasteurization. It's a small but necessary amount for coagulation to occur. After that, I add the enzyme and wait for it to act. How does it work? It creates calcium bridges between casein proteins, forming the gel we'll see later.
So the enzyme helps a chemical reaction that firms up the cheese, causing it to start solidifying.
It breaks the protein open, allowing it to bond with calcium.
In chemistry, an enzyme is a substance that speeds up reactions. And what we want here is to speed up milk coagulation to separate the liquid part from the solid part. That's right. Milk isn't a homogeneous liquid. If you look under a microscope, you can see particles, proteins, and fats suspended in water. The white little spheres here are milk fat. The darker ones are casein, a protein used in cheese, and also the protein in whey protein. We won't be able to see the latter because it's extremely tiny. Rennet, which is the commercial name for the chymosin enzyme, will speed up this separation. This one is synthetic, but in nature, it's found in calves' stomachs to help them digest milk. So what's happening here is that the rennet will turn liquid milk into curds. And this process takes about half an hour. Look at the difference. Now the proteins have joined together, forming a gel. And this movement causes the whey to start separating out. You can see it's becoming more and more distinct. We can see more and more whey here. Is this liquid part? You can tell it's transparent with a slight greenish tint. And this is where whey protein comes from. It's right there in the name. It means whey and whey protein. It means whey protein. Let's open this up to separate the whey from the curds. There's an audience behind me saying, "I'll take a whey shower if I'm not careful." Let's see. Can't say they didn't warn me, right? The The whey is draining out here, but inside, the curd is already firm and ready. So it'll go into a mold where we'll remove even more whey. We could already call this mass cheese, but it still needs to rest. And this one here has already rested for a day. It's ready to eat. Let's taste it, shall we? If the whey turns out this good, that'll be great. To make 1 kilogram of cheese, you need 10 liters of milk and 9 liters of whey are left over for a long time. This whey from cheese production was either fed to animals or simply discarded, but it contains proteins and lactose, the sugar in milk, that's organic matter. If dumped into nature, it feeds microorganisms that consume oxygen from the water, harming aquatic life, and that's where food engineers come in. It's a relatively new profession that blends engineering with chemistry, physics, biology, and nutrition.
The role of a food engineer is to ensure food production for everyone, making food that's safe, healthy, tasty, and sustainable.
Here at MAWA, students have access to a pilot plant that simulates factory processes for dairy sausages, meats, breads, and beverages. It's ideal for putting classroom theory into practice. So it was food engineers who studied how we could make good use of milk whey. And that's how dairy drinks and powdered supplements were born. To get these products, the first step is to sieve and filter the whey. The goal of this machine is to keep the protein and remove the water and lactose, the milk sugar. How does it do that? The whey I poured in passes through a filter, a membrane with extremely tiny pores. Only water and lactose can pass through, so it separates the part to be discarded and recirculates what couldn't pass through for another round of filtration. So we have a cycle where water and lactose are continuously removed, leaving behind a liquid increasingly rich in protein. Look, I honestly thought this filtering membrane was like a coffee filter. Nope. It's this. It sits inside the machine like this, and if we look inside, we can see where the whey flows. The water and lactose exit on the outside while the proteins stay inside. It really blocks the molecules. This is the permeate, the leftover water with lactose. Professor, why is it green?
Actually, it's yellow because the pigment that gives it a yellow color is riboflavin, vitamin B2, casnopimia, which is present in the water found in whey milk. And in this case, the permeate. The thing is, riboflavin changes color when exposed to sunlight for too long, so it turns greenish, right?
I was starting to think I was colorblind.
No, that's not it. That's why milk and dairy packaging need light protection.
Can I take a sip of this?
Go ahead and take a sip.
The things I come up with. Here goes, they said it tastes like sugary water, right? Yeah, it really does taste like sugary water. If I'd tasted it blindfolded, I'd have said it was milk. It's good, it's good. Let's see how the concentrate comes out. Hope I don't get another shower like I did with the whey. This concentrate could already be drunk as is. It's equivalent to those liquid whey products sold commercially, except this has no additives. Of course, we're going to taste it a bit, right? Well, the water with lactose was tastier, but I'll say this is better than the average whey protein shake you usually drink. If we added some flavor, I think it'd be even better. I'll add some Belgian chocolate flavor here because nobody deserves to drink bland protein. But to make powdered whey, we still need the drying step. The magic happens in this machine here. It's called a spray dryer. We have the protein dissolved in water. It gets pumped inside, and high pressure air is injected alongside it. There's a nozzle that sprays it, just like a deodorant, into very tiny droplets. At the same time, the machine blasts a huge amount of hot air inside at around 160 degrees. So those droplets instantly dry and fall into this container below. Some powder remains airborne, so the air flows into this cyclone. All solid particles hit the cyclone walls and drop into this second container. The temperature is high, But everything happens so fast the protein molecules don't get damaged. So theoretically, we now have powdered whey protein. Let's see. So it comes out as an extremely fine powder, almost invisible here. But there's already some inside the jar. As usual, I made a mess, but check this out. The whey protein you buy at the supermarket is exactly this. Look how cool, Lundy. Thanks to science and technology, we've turned a byproduct, once discarded in cheese production, into a supplement used by athletes and many people who exercise regularly. You're probably wondering if it tastes good. It actually smells nice too, but let's call over the student athletics team to try this. It's a taste test, but I'll also use it as a sincerity test. In the last 2 cups, I'll add a pinch of salt. Will whoever drinks it still say it's tasty? Let's find out. Hey guys, we just filmed a video showing how whey protein is made. I actually made it myself, but we need to see if it turned out well. So, you folks, being athletes and all, are perfect guinea pigs. To try the whey protein I just made. Who'd like to volunteer for a sip? Everyone. Then, let's raise a toast to Mawa, and afterward, they can tell us if it's good.
Okay.
It is good. It is good.
Approved?
That's tasty.
Did everybody think it was good? There are 2 cups, I put salt in them.
It wasn't mine. It's not
It must be in yours.
This group's really paying attention, huh?
Let me see. Then, we'll put it here.
There's a difference.
But, like, what makes the difference is that it's just sweeter.
But it didn't turn out bad.
No, even with salt?
Come try it. Is it different?
Just sweeter.
It turned out so good. Even with salt, you can be fooled.